This is a work solution to AQA Physics P2 June 2013, higher tier paper, question 5. Iodine has 53 protons and the 131 represents the number of protons plus neutrons, so the number of neutrons is 131 minus 53, which is 78. The number of protons in an atom is called the proton number, or it's also known as the atomic number of that atom. It goes on to tell us in part C that an atom of iodine 131 decays into xenon by emitting a beta particle. In beta decay, a neutron in the nucleus is converted to a proton and it releases a beta particle. So we would expect the neutron number to go down by 1 and the proton number to go up by 1. So instead of 53 protons, we would have 54 protons. And the top number 131 is unchanged because a neutron has turned into a proton, so that total of neutrons and protons doesn't change. In 5C part 2 is about half-life. It tells us that contaminated rainwater gives us an activity of 1200 counts per second and the half-life is 8 days. That means every 8 days this will halve. So in 8 days it will go from 1200 to 600. In another 8 days it will go down to 300. In another 8 days it will decrease to 150. And then another 8 days it will halve again to 75. So that was 8 days plus 8 days plus 8 days plus 8 days, which is a total of 32 days. So in this case it was 4 half-lives, and that's 32 days. In 5C part 2, if people drank the contaminated water, and the iodine builds up in the thyroid gland, and until the thyroid gland is saturated and can't absorb any more, and that gland would then be radioactive because of the iodine in it, and that could cause cancer in the thyroid. So instead, in Japan, immediately after the radioactive leak, people were given tablets which contained a non-radioactive version of iodine. And what that would do is the non-radioactive iodine would be absorbed by the thyroid gland. So the thyroid and by absorbing that, it limits the amount of the radioactive 131 that can be absorbed. And if you limit the amount of radioactive isotope taken up, it reduces the risk of cancer.